Today we'll see the sorting and searching algorithms, few of them. One of them is binary search. It works by repeatedly dividing the search interval in half. Okay, so let's say this is the input 1 3 5 7 9. The target is 7. We need to look into 7. So what it does, it repeatedly breaks this into half, meaning like this. So left equal to 0 and right equal to minus 1. So half is left plus right divided by 2, and then it will compare with the target. If the target is found, then it is given as mid. If it is less, it will go to the left side of the array, and if it's right, if it's greater, then it goes to the right side of the array. So obviously it has to be sorted before. So if the value is key is less, it goes to the left. If it is right, it's vice versa. The time complexity is O log of n and makes it very efficient for large data sets. It's very efficient. Okay. The disadvantages is the array must be sorted. Okay, so that's how it is. So the logic is this one in this line, math.floor of left plus right divided by 2. So then it's going to compare. If it is the same, mid. If it is less, go to the left side, and then again go to the while loop, and then if it's right, again go to the right, and again it goes to the while loop. Okay, so that's how it is. Now next is linear search. It is also called as sequential search, meaning that it checks each element one by one until the desired element is found. Okay, desired element is found until it reaches the end of the list. The disadvantage is it's inefficient for large data sets. The time complexity is O of n. Before it was O of log n, and now it is O of n. Linear search, and it makes slow for large data sets. So how does it do is, so let's say this is the input and the target is 7. So what does it do is, it takes the for loop for all the elements one by one. It checks for the target. If it is there, then it is fine, it returns the index. If not, again it repeats, just very conventional way, just one by one. Okay, next is bubble sort. It's basically a simple sorting algorithm that again repeatedly steps through the list. It compares adjacent elements and swaps them if they are in the wrong order. It just swaps. The disadvantage is O of n square. So before it was O of n, and before binary search it was O of log n. Binary search O of log n, linear search it is O of n, and bubble sort it is O of n square. That is in the average in the worst case. It also makes inefficient for large data sets, right? So what it does is, so let's say this is the input and we wanted to sort it out. Okay, so what it does is, so first it will say n equal to array dot length, then swapped. So traverse through all element, each and every. First it is swapped is false, and then again two for loops. First one is the normal, and the second is from the second element itself, or else from the n minus 1. So from the reverse order, I guess. And then if a of j, so it will compare each element with the next one, and then if it is greater, just swap. If it is less, just keep it like that. If it is greater, just swap. So how does it swap is, this is the logic. Array a of j comma array a of j plus 1 equal to array of j plus 1 comma array of j. So like that it's going to swap. So what are the three? Bubble sort, linear search, and binary search. Thanks.